Hi, this is chapter 18 on acid rain. Acid rain, so rain that is more acidic than normal rain, usually tied to human emissions of sulfuric dioxide and nitrogen oxides. These are the NOx I was trying to explain last time. Um, it damages structures and outdoor sculptures because it just erodes things because it's acidic. It's not like crazy acidic. It's not like it burns your flesh off. It's just kind of slightly more acidic, but still increases the rate of erosion. Plants can suffer defoliation where they lose their leaves or their growth may be stunted. And then fish are very sensitive to pH conditions, so they can be killed. pH reports the concentration of hydrogen ions in a solution. So if it's acidic, so neutral is 7, acidic is under 7, and basic is over 7. So our alkaline would be basic. Okay. Um, so here we've got the formation of acid rain where the gases come from any of these sources. It reacts with water, H2O, and releases a hydrogen atom, and that becomes acidic rain. I'm sure we're gonna have. I actually meant to delete this slide. Here's a picture of the trees that have lost their leaves from acid rain. Oh my goodness, it actually doesn't give like the chemical reaction. Let's see if I can't in a book. Read that off real quick. Yeah, taking me too long to find it, isn't it? I don't know it off the top of my head. Uh, No, it doesn't. I suppose it did back in this lecture, didn't it? Anyways, it becomes like H2SO4. Um, then carbonic acid is produced too with the carbon dioxide. Okay, yeah, here it is for the sulfur. SO2 plus H2, so sulfur dioxide plus water plus a little bit of oxygen is sulfuric acid, which is H2SO4. And then we have nitric acid, which is the nitrogen dioxide plus water vapor, and a little bit of oxygen is nitric acid, which is 2HNO3. And then there's one for carbonic acid too, which is very similar, but I can't find it in here. All right. And then let's see, regional variations and impacts. Rain downwind of industrial or populated areas is more acidic because that's where it comes from. Industrial areas have notably higher sulfur dioxide emissions than non-industrialized areas. Urban areas with vehicles generally have higher nitrogen oxide emissions than areas without cars. Local geology can reduce the acidity of waterways that receive acid rain, especially limestone can neutralize acidic water. The acid just kind of eats at the limestone and so the limestone like neutralizes it as it's dissolving it away. Granite cannot buffer acidic effects in soils because it's kind of acidic itself. And then here's a couple of maps from 1990 and then 2020 that show the reduction of the acid. And I'm not sure what they tested, if this was in lakes or rainfall or what, but it's definitely been reduced. And that is it for acid rain.